Hi, I'm Kevin Moon, and I'm presenting this video abstract on our paper. For many UAV applications, we need to know where the UAVs are and where they're going, which is typically obtained using GPS. However, there are some scenarios where the GPS signal may be denied. Our work shows that SAR can aid with this. SAR images are created using the backpropagation algorithm, which requires us to know the flight path. Inaccuracies in the flight trajectory can lead to distorted images. So we trained a neural network to learn the navigational errors from distorted images by comparing the distorted image with a reference image. We know that we only need to estimate the initial navigation errors. We tested our approach using both real and simulated data. For the real data, we tested multiple SAR aperture lengths, as longer lengths can propagate the errors more. And we use different mixtures of errors, as there can be ambiguity where different navigational errors result in similar image distortions. We input the distorted image, the reference image, and the difference between the two into a pre-trained convolutional neural network and then train it further on our data. Here are the results on the simulated data. And a mean squared error value less than 1 indicates that some learning is occurring, which occurs for all of the errors in all 6 scenarios. As expected, the real data is a bit more complicated, and the aperture length has an impact on our results. However, we find that varying the aperture length can help us in some scenarios. Regardless, there are some scenarios where error ambiguity exists, such as in scenario 6. In conclusion, we successfully trained a CNN to estimate initial position and velocity errors from distorted SAR images. The network performs well in the absence of error ambiguity. We also found that increasing the aperture length improves performance in blur-related errors. Future work including auxiliary information about viewing geometry. And thank you.